Do 3 of 3 on mass diagrams, and now we're going to be focusing on two main things. One, determine the average haul distance, and the second one is also determining the average grade of where we are conducting our operations. We are going to be using the information that we're going to be going through and analyzing to solve a problem and figure out the cost of a certain earthwork operation based on the mass diagram or using the mass diagram. So let's go ahead and start with determining average haul distance. And average haul distance in basically is, if you look up there, this is the mass diagram. If we are trying to compute an average haul distance, we are trying to figure out two major things. One would be the cross-hatched area of the station in the section that we're interested in. Remember, we talked before about moving the cut from, for example, station, the one you see up here, from station CD to station DE. So if I would like to figure out what the average distance would be from station D to E, then what I would do would be that I would divide the area underneath the curve, which is really QCD, the area under here, the area that is encompassed by QCD, divided by QCD, which is the quantity. So let's zoom in a little bit. The average haul is going to be the cross-hatched area, which is determined in bank cubic yard feet, divided by bank cubic yard. Let's look a little bit more into, if we want to get it in a faster way, what we would do is that we are going to be basically thinking about the direction of the haul, first of all, which is from this section A to B, moving to B to C. So you're cutting in AB and then you're filling in BC. If you look at the mass diagram at the bottom, there are two main things that we're interested in. One is going to be my average haul distance, and the other one is going to be my Q. The material needed to be moved from AB to BC technically does not have to move for the entire distance, right? So not all the quantities are going to be moved from A all the way to C. And this is where the term average distance comes from, and this is what I was talking about in the previous slide, being determined as bank cubic yard feet, the average distance. All right. The average haul distance will be computed by computing, or will be calculated by computing the area under the curve and then dividing it by the quantity, which is the maximum vertical distance between the balance line and the curve. So if you look down here, you see there's the maximum haul distance, which is, if assuming that we're going to move all the way from A to C, which is really not going to happen. So what we're going to do is that we're going to try and compute the average haul distance, which is here. And to get the average haul distance, we need to figure out the area under the entire curve and then divide it by the Q. Another thing we need to determine, and I was just mentioning that in the previous slide, is the balance line. Which area am I determining? And the other part of the story, which was covered in previous slides, it was the first video, was basically deciding on which type of equipment to use. Of course, if you are moving moving material using dozers, that's probably a smaller haul distance, versus if you are using scraper, a larger haul distance. So in this specific curve, what you see is that we have divided our area into cutting and filling this quantity, which is for the scrapers, and then cutting and filling this quantity, which is for the dozers. Meaning that we are going to be cutting CD and then filling DE, or cutting AC and then after that filling in EG. This is a table that shows the stations, the end area cut and fill that we guys have done before when we were talking about the average end area method, and then going all the way to figuring out the cumulative cut and fill that you see at the very end here. Now the cumulative fill that you guys see at the very end here is technically the ordinance that we're going to use to plot our mass diagram. Now, when we are actually computing the mass diagram, when we're trying to basically draw it, we are going to end up with something like that. Now, if you look at the curve below, there are a few important things to note. For example, you guys can see the hauls, haul 1, haul 2, haul 3, and these are determined by the balance lines. We do have our primary balance line, and haul 3 is encompassed here in this area, and I'm going to show you how we came up with that. And then we have our haul 1, which is really this area, and then we have our haul 2, which is this area. Hall 1 goes all the way between stations 2 and 3, all the way to station 8. Hall 2 goes all the way from station 8 to actually down here to station 13 and 14, between 13 and 14. Hall 3 goes all the way from station 0 till the very end of the project site. These peaks and valleys, which we are going to be looking at a little bit closely, are important because they determine for us the Q factor of the average haul distance. So remember we said the average haul distance is going to be the area divided by the Q. Well, if I can get to know the Q for each haul, that's going to help me get one of the parameters. Now, this haul 1, or this first sort of peak, goes all the way to the one you see here, 28,539, which is really when it starts, goes from 27 up to 28 and then down again to 25. So that's why we call it a peak, okay? And then this, we're going to haul 3, we're going to call it really technically a valley because it goes up and then it goes down and then it goes up again, so it's 17,000. And then again, we end up with another peak here, which is going to be my 22,670. Now, why do I need these numbers? I need these numbers because these numbers are going to be determining for me, my next slide here shows my Q. So the Q's down here is going to be technically the sum of the absolute value of the peaks minus the lowest point. So for example, in this case, my first haul is going to be between the 28,539 I see up here and between the 17,080, which is down here. My second haul, haul 2, is going to be between 22,670 and down to also the same number, 17,080. My last haul is going to be 17,080 minus 0, which is going to make it 17,080. This is really determining for me the entire amount of excavation to be done in haul 1, haul 2, and haul 3. This gets us the Q, but now what about the area? Let's look a little bit closely into the curve. To determine the area, what we need to do is we need to get the sum of these vertical distances at every single station for every single haul. So if we're interested in haul 3 per se, the area is going to be the Q at 0, Q at 1, Q at 2, Q at 3, Q at 4, all the way to Q at 15, right? Or technically it stops at 14, Q at 14. So sum them all up, this is going to give you the area. So let's do that. So for station 1, this is the number 3631. Station 2, the number is 13641. Station 3, the number is 17080, which goes all the way to 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. They have the same exact number, 17080. And then finally, station 14, we have 8502. Now, if you sum up all these numbers and, of course, encompass the 17083, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 times, this is going to give you the sum, which is really the area under this curve, which is between the auxiliary balance line and the primary balance line. So area under haul 3 divided by quantity hauled. So what is the quantity hauled? We just mentioned from the previous slide. Haul 3 extends from the primary baseline all the way till here, which was identified as 17,080. So this 213,654 is really the sum of all these red numbers you see with 17,080 multiplied by the number of stations. This gives you a average haul distance of 12.51 stations, i.e. this is telling you that really on average the distance that is going to be traveled all the way to move the cut from station between, in this case, 13 and 14 all the way to station 0 and somewhere in 2 is going to be an average of 12 stations, 12.51 stations. For the other hauls, if you look closely into the curve, like we said before, the volumes for haul 1 per se, 11,459 was technically the peak, which was the 28, I remember, minus the 17, which gives you around 11,000 bank cubic yard. Now you're going to compute the sum of the verticals or the average haul distance, and the same entire idea in which you're going to be basically summing up the Q at 3, at 4, at 5, at 6, and then at 7, and then dividing the sum of Q by the 11,459, which is your quantity, and that's going to give you the stations that you see here. This is going to also happen in haul number 2. The second in line is to determine the average grade. It is very important to figure out where my equipment are going to be moving and how they're going to be moving, from which side to which side, and on what's the slope. So if you look again into the mass diagram, you look down here, the way to go about this is basically that you will need to look up onto the profile that's plotted at the top one, which is this profile. And then when you look at the profile, you are going to be trying to approximate the average haul grades. So you want to draw a horizontal line that roughly divides the cut area in half in the vertical dimension, which is really what you see DE here and what you see GF here. So this vertical, you're dividing into 2, and then you're plotting a horizontal line, and this horizontal line intersects with the profile, the Earth that's down here. Now these 2 points that intersect with the profile is going to be basically the vertical distance between these 2 points are going to be my 18 feet, which I'm going to use to determine the slope by also figuring out what my average haul would be. And in this case, my average haul was given to me, or I can actually even compute it as 203 feet. The difference in elevation between these 2 lines provide the vertical distance to use in calculating the average grade for the haul involving the material in the balance. The average haul that we look down here as determined by the construction of a horizontal line on the mass diagram, and it's basically this distance. So if you look into computing it, this is your average haul, and now this is your horizontal line. Your horizontal line up there, the distance between them is 18 feet. The average haul is 203. Change in elevation divided by average haul distance times 100 is going to be giving you your average grade from cut to fill. Now it's the time to actually go ahead and try and apply what we have learned so far into a problem. This problem is going to be very neat because it's going to link the cost factor to the mass diagram and see how you're going to be using that mass diagram to determine the cost using various pieces of equipment. In this specific example, we are going to be using a self-loading scraper. Okay, so the example says, determine the total cost and the cost per cubic yard for the earthwork of the first balance point of a mass diagram that I'm going to show you in the next slide. The self-loading scraper with a truck capacity of 15 cubic yard will be used to excavate and haul the soil. So basically, this is a scraper that basically will load the soil, excavate it and haul it, and then it's going to take around 0.8 minutes to load it, 0.7 minutes to dump it. It travels at a speed of 18 miles per hour, and when it's basically hauling, and at a speed of 22 miles per hour when it's returning, and the material has a swell factor of 25%. And if you look into the mass diagram, which we're going to look into in a second, it's actually going to be divided into 3 hauls or 3 sections, each with a quantity that to be moved of 200 cubic yards. There's also 45 minute-hour efficiency to consider. All right. Up there, your profile basically of the earth where you are moving and showing you the existing versus the final. As you start, you have a big chunk of cutting. Moving on, you have some filling to do, and then moving on again, you have some cutting to do. So if we were to actually, how did I get this mass diagram? Well, it's given to us here, but if you want to think about it, basically what happened is that we moved at every single 100 feet station, and then we computed the amount of cut and the amount of fill, and then from there we actually got our cumulative, and then we plotted using basically these numbers our mass diagram. So the amounts that we see on the top are obviously our cuts, and the amounts that we see at the bottom are our fills. Now let us look a little bit into more detail. What is our end product? Our end product is we find a cost. How do you find a cost? You find a cost by finding the amount of time. How do you find the amount of time? You find the amount of time by finding the productivity. How do you find the productivity? You find the productivity by finding the cycle time using these pieces of equipment. Okay, so now the tricky part of the story is that the equipment is going to be moving, right? There's in 3 different halls, which is hall 1, hall 2, hall 3, based on 3 different distances. So we actually need to compute the productivity for hall 1, for hall 2, for hall 3, and then from there figure out the amount of time it takes to move these 200 cubic yards for hall 1, for hall 2, for hall 3. Let's go through the problem. You start off by thinking of the capacity of the scraper, which was given to us as 15 loose cubic yards. So this is how much the scraper can take. However, if you think about our properties of the soil, we do have a swell factor of 0.25, so we will need to take that into account. So this 15 loose cubic yard is going to be divided by 1.25, giving you 12 bank cubic yard, which is what I technically need, because really the quantities are also in bank cubic yard. All right, I'm going to put together a table in which I'm going to determine it for each hall, for each section 1, section 2, section 3, what the quantity is, which are 200, 200, 200. This was given to me in the problem. If they were not given to me in the problem, let me go back. I will need to determine my halls, and these halls are going to be determined based on the pieces of equipment I'm using. And then once I determine my hall, I'm going to determine the quantity, which is going to be the vertical distance that is between the curve and the auxiliary line, or in this case, this hall 2 is going to be between the auxiliary line and the auxiliary line. In 3, it's going to be between the auxiliary line and the primary balance line. So in this case, it was divided evenly into 200 cubic yards, as you see, 200, 400, and then 600. All right, so I have the 200s for each one of these, 1, 2, and 3. Now what I need to determine is going to be figuring out the distance. Now it is no surprise. What is the distance for hall 1? This is going to be my average hall distance. Let's go up. My average hall distance is given to me as 2,000 feet for hall 1, for hall 2 is 3,400, and for hall 3 is 4,300. So I'm going to start with hall 1, and I'm going to use the 2,000 feet. Now, after I put my 2,000 feet, I will need to go through figuring out the cycle time, which are all these numbers you see here. We are going to use the numbers that are given to us in the problem, starting with the load at 0.8 minutes. So this is a given number. The hall is going to be using the distance, which is the 2,000 feet that is shown on the mass diagram, and then dividing that distance by the speed, making sure you do your proper conversion to get it in minutes. My dump is a standard number of 0.7 minutes, and then my return is the same as my haul, but the only difference is going to be my speed, which is 22 miles per hour. These 3 numbers are going to give me a total, which is the cycle time, very similar to what we have been doing before in class in equipment, which is 3.79. Now that I have 3.7 minutes to finish one cycle, the question is how much quantity is in one cycle, and that is why this piece of information was important, because the capacity of the scraper is technically 12 bank cubic yard. So all what I need to do to figure the production rate using the quantity hauled per trip is going to be dividing that 12.12 cubic yards by my 3.79 and making the proper conversion to get it in hour, and then this 45 by 60 is going to include the efficiency. Moving on, how do I get my total time? Well, I know that it takes 142.8 cubic yards per hour. That could be finished in an hour. If I have 200, it's probably going to be an hour and a little bit more. So it's going to be an hour 1.4, which is 200 divided by 142.8. This is just for hall 1. We can repeat the same exact thing for hall 2. The numbers are similar. The only differences you see are going to be in my haul and in my return. And guess why this is happening? This is happening because of the different distance. The same 12, use of the scraper, the capacity now gives you the production rate, which is going to be dividing your 12 by 5.4 and then divide by and do the proper conversions to get it in hours, because these are in minutes, right? And then after that, you get your total time by dividing your 200 by 99, which means 2 hours. Same exact thing for the third row, and then you get your total being 5.8 hours. So for this area, basically, or for this length of the profile, starting, that covers halls 1, 2, and 3, for these stations, it takes 5.8 hours to do the cut and fill. Okay, this is how much time it takes to do the cut and fill. Now, 5.8, the question asks you what would be the cost. Well, okay, if I know that it takes 5.8 hours to do the cut and the fill, then I'm going to be using the scraper and the operator for the entire 5.8 hours. Give me the rate for the scraper and the rate for the operator. I'm going to get you the cost. This would be the total cost for this operation, for this piece of the operations, halls 1, 2, and 3. Now, if I want to ask what the cost per cubic yard would be, that's going to be my entire dollar total cost divided by my entire total quantity. And that's going to give you 727 divided by 600 at $1.21 per cubic yard. This actually concludes our mass diagram lectures. What you guys will need to do next is to actually go back, and I'm going to post the quiz so that you can see it, but you need to look into this problem that we are solving right now. Let's look at it. And what I would like you to do is to determine the total cost for this section, which is halls 4 and halls 5. So all what you need to do to determine for hall 4 and 5 is you are going to be setting up the same exact table. You are going to be putting sections 4 and 5. You have the same amount of quantity. You have different distances. You have the same load, the same dump. You have different haul, different return. You're going to get a different total. You have the same 12 cubic yard that's being used for the scraper. The production rate is going to be different because you're going to be basically using the cubic yards and the total cycle time that you get from here to get your production rate. Get your total time and total time in hours, and then use the total times in hours multiplied by the dollar values you have for the scraper and the operator and get the total cost. So that is really technically your quiz that you will need to complete. This concludes the mass diagram. Please go ahead and solve your quiz on Blackboard.